Learning objectives. At the end of this topic, you will be able to understand angle sum property of a quadrilateral, identify types of quadrilaterals, illustrate properties of a parallelogram. Introduction. Quadrilateral. A quadrilateral is a four-sided polygon with four angles, but the sides have to be straight and it has to be two-dimensional. Consider 4 points on the plane such that no 3 points lie on a same line. Join the points in clockwise or anti-clockwise direction. A four-sided closed figure is formed. This is called a quadrilateral. A quadrilateral has 4 sides, 4 angles, and 4 vertices. In quadrilateral ABCD, AB, BC, CD, and DA are the 4 sides. A, B, C, and D are the 4 vertices. Angle A, angle B, angle C, and angle D are the 4 angles formed at the vertices. AC and BD are the 2 diagonals of the quadrilateral ABCD. Angle sum property of a quadrilateral. Now let's prove a property which holds true for all types of quadrilaterals. Do you remember the sum of 3 angles of a triangle? Yes, it's equal to 180 degrees. Using this property of a triangle, we will show that the sum of 4 angles of a quadrilateral is equal to 360 degrees. Let ABCD be a quadrilateral and a diagonal divides it into 2 triangles. Since the sum of 3 angles in each triangle is 180 degrees, the sum of the angles of a quadrilateral is equal to 360 degrees. Let's prove this theorem. Prove that sum of 4 angles of a quadrilateral is 360 degrees. Consider quadrilateral ABCD. AC be a diagonal such that it divides the quadrilateral into 2 triangles, ADC and ABC. We know that the sum of 3 angles of a triangle ABC is equal to 180 degrees. Angle CAB plus angle ACB plus angle B is equal to 180 degrees. Consider this as equation 1. Similarly, in triangle ADC, angle DAC plus angle ACD plus angle D is equal to 180 degrees. Consider this as equation 2. Adding equations 1 and 2, we get the sum of the angles is equal to 360 degrees. Also, angle DAC plus angle CAB is equal to angle A, and angle ACD plus angle ACB is equal to angle C. This implies angle A plus angle D plus angle B plus angle C is equal to 360 degrees. Thus, the sum of the angles of a quadrilateral is 360 degrees. That is, the sum of all the angles of a square, a rectangle, a parallelogram, a rhombus, a trapezium, and a kite is equal to 360 degrees. Types of quadrilaterals. Here we will learn more about different kinds of quadrilaterals, their properties, and especially those of parallelograms. Quadrilaterals can be classified into different types based on their sides and angles. Let's learn about each of these quadrilaterals. Consider the first 2 quadrilaterals. The first quadrilateral is a square and the second is a rectangle. 4 angles of these 2 quadrilaterals are right angles. In each case, the opposite sides are parallel. The difference is the length of their sides. A square has 4 equal sides, while a rectangle has opposite sides equal in length. The diagonals of squares and rectangles bisect each other. In case of a square, they bisect at right angles. Thus, a square is a rectangle with adjacent sides equal. Now let's consider the third quadrilateral. If we compare it with a rectangle, we see that it's different from a rectangle in terms of the measurement of its angles. Observe, its angles are not right angles. However, the opposite angles are equal. Such a quadrilateral is called a parallelogram. Let's define it. A parallelogram is a quadrilateral in which the opposite sides are parallel and opposite sides are equal in length. Opposite angles are equal. Diagonals bisect each other. Now consider the fourth type of quadrilateral. On comparing this quadrilateral with the square, we find that most of the properties are the same. However, unlike the square, its angles are not right angles. Such a quadrilateral is called a rhombus. A rhombus is a quadrilateral in which all sides are equal in length, opposite sides are parallel, opposite angles are equal, and diagonals bisect each other at right angles. Thus, we can say a square is a rhombus in which each angle measures 90 degrees. Now let's consider the definition of all quadrilaterals. A square, rectangle, and rhombus are all examples of parallelogram. The relation between these can also be represented as shown. Now let's consider the remaining quadrilaterals. Note, these quadrilaterals are quite different from the ones we just learned. This is a trapezium. It's a quadrilateral in which one pair of opposite sides are parallel. Now use a special trapezium. Its non-parallel sides, as you can see, are equal in length. Similarly, if you measure the base angles, you will see that both are equal. Thus, a trapezium having non-parallel sides equal and base angles equal is known as an isosceles trapezium. Now let's consider the last quadrilateral. This shape looks familiar. Yes, it's similar to a kite. You must have seen them flying in the sky. This quadrilateral is called a kite. Now let's learn more about a kite. A kite is a quadrilateral in which two pairs of adjacent sides are equal in length. One pair of opposite angles, the angles that are between the sides of the unequal length, are equal in measure. Also, one diagonal bisects the other and diagonals intersect at right angles. Properties of a parallelogram. Now let's learn about the properties of a parallelogram with the help of an activity. Consider the parallelogram. Let's draw a diagonal line, any of its two opposite vertices. It divides the parallelogram into two triangles. The two triangles coincide means the corresponding sides of both the triangles are equal. This implies the diagonal of a parallelogram divides it into two congruent triangles. Since the triangles are congruent, their corresponding sides and angles are equal. Thus, we conclude in a parallelogram, opposite sides are equal and opposite angles are equal. Now join the other two vertices. It divides the parallelogram into four vertices. Consider these two. On placing one over the other, you will observe they also coincide. This implies that corresponding sides are equal. Thus, we can say that the diagonals bisect each other. You can also repeat this activity with some more parallelograms. Observe that each diagonal divides the parallelogram into two congruent triangles. Let's prove some of the properties of the theorems. A diagonal of a parallelogram divides it into two congruent triangles. Let ABCD be a parallelogram and AC be a diagonal. Observe that the diagonal AC divides parallelogram ABCD into two triangles, namely triangle ABC and triangle CDA. We'll prove here triangle ABC is congruent to triangle CDA. In triangle ABC and triangle CDA, note that BC is parallel to AD and AC is a transversal. So, angle BAC is equal to angle DCA and side AC is common to both the triangles. Thus, from equations 1, 2, and 3, two angles and the included side of triangle ABC are equal to the corresponding two angles and the included side of triangle CDA. This implies triangle ABC is congruent to triangle CDA by ASA congruence rule. Thus, the diagonal of a parallelogram divides it into two congruent triangles. Hence the proof. Now continuing with the same parallelogram which is divided into two congruent triangles. by CPCT, we can say that the corresponding sides of the two congruent triangles are equal. That is, side AB is equal to DC and AD is equal to BC. Thus, we conclude, in a parallelogram, opposite sides are equal. This is another property of a parallelogram. Also, corresponding angles are equal. That is, angle B is equal to angle D. Similarly, on drawing the other diagonal, we get angle A is equal to angle C. Thus, we conclude, in a parallelogram, opposite angles are equal. Now, let's prove the next theorem. If, in a quadrilateral, each pair of opposite angles is equal, then it's a parallelogram. Draw a quadrilateral ABCD, where AB is equal to CD and AD is equal to BC. To prove quadrilateral ABCD is a parallelogram, we need to prove that the opposite sides are parallel. Draw a diagonal AC. In triangle ABC and triangle CDA, side AB is equal to side CD, denoting it by equation 1. Side AC is common to both the triangles, denoting this by equation 2. Side BC is equal to side AD, denoting it by equation 3. Thus, the three sides of the triangle ABC is equal to the corresponding three sides of the triangle CDA. Therefore, by SSS congruence rule, triangle ABC is congruent to triangle CDA, since the corresponding parts of the congruence triangles are equal. Therefore, angle BAC is equal to angle DCA, and angle BCA is equal to angle DAC. On adding, we get angle A is equal to angle C. Also, angle B is equal to angle D by CPCT. This implies that opposite angles of the quadrilateral ABCD are equal. We know that quadrilateral is a parallelogram if the opposite angles are equal. Hence, the quadrilateral ABCD is a parallelogram. Now let's prove another theorem. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Let ABCD be a quadrilateral in which the diagonals bisect each other. This implies BE is equal to DE and AE is equal to CE. We need to prove that quadrilateral ABCD is a parallelogram. In triangle AEB and triangle CED, we have given side AE is equal to side CE. We denote this as equation 1. Angle AEB is equal to angle CED, since they form a pair of vertically opposite angles, denoting this by equation 2. Also, side BE is equal to side DE, denoting this by equation 3. From the above equations, two sides and the included angles of triangle AEB are equal to the corresponding two sides and the included angle of triangle CED. Thus, by SAS congruence rule, triangle AEB and triangle CED are congruent. Now, since the corresponding parts of the congruent triangles are equal, therefore, angle AB is equal to angle CDE, which are the alternate interior angles for lines AB and DC, and transversal DB. Thus, AB is parallel to DC. Also, by CPCT, AB is equal to DC. Thus, quadrilateral ABCD is a parallelogram. Let's see some example problems here. Show that each angle of a rectangle is a right angle. Solution. We know that a rectangle is a parallelogram in which one angle is a right angle. Consider a rectangle ABCD in which angle A is equal to 90 degrees. We have to show that angle B is equal to angle C is equal to angle D is equal to 90 degrees. Here AC is parallel to BD and AB is a transversal. Since interior angles on the same side of the transversal is 180 degrees, so angle A plus angle B is equal to 180 degrees. But angle A is equal to 90 degrees, so angle B is equal to 180 degree minus angle A. That's equal to 180 degree minus 90 degrees, which is equal to 90 degrees. since opposite angles of the rectangle are equal. Therefore, angle C is equal to angle B and angle D is equal to angle A. So, angle C is equal to 90 degrees, angle D is equal to 90 degrees. Therefore, each of the angles of a rectangle is a right angle. Now consider the second example. The angles of a quadrilateral are in the ratio 4:6:8:10. Find all the angles of the quadrilateral. Let the common ratio between the angles be x. Therefore, the angles will be 4x, 6x, 8x, and 10x respectively. As the sum of all the interior angles of a quadrilateral is 360 degrees. Therefore, 3x plus 6x plus 8x plus 7x is equal to 360 degrees. On simplifying, we get x is equal to 15 degrees. Now substitute the value of x. Hence, the angles are 45 degrees, 90 degrees, 120 degrees, and 105 degrees. Next example shows that the diagonals of a rhombus are perpendicular to each other. Consider the rhombus ABCD. We know all the sides of a rhombus are equal. So AB is equal to BC is equal to CD is equal to DA. Now in triangle AOD and triangle COD, OA is equal to OC since diagonals of a parallelogram bisect each other. OD is the common side. AD is equal to CD. Therefore, triangle AOD is congruent to triangle COD by SSS congruence rule. This gives angle AOD is equal to angle COD by CPCT theorem. Also, by linear pair, angle AOD plus angle COD is equal to 180 degree. So, 2 times of angle AOD is equal to 180 degree or angle AOD is equal to 90 degree. So, the diagonals of a rhombus are perpendicular to each other. Another condition for a quadrilateral to be a parallelogram. A quadrilateral is a parallelogram if a pair of opposite sides are equal and parallel. Given BC is equal to AD, BC is parallel to AD. We need to prove that quadrilateral ABCD is a parallelogram. Draw a diagonal AC. Now let's prove the theorem. In triangle ABC and triangle ADC, angle ACB is equal to angle DAC. Since alternate interior angles are equal, AC is a common side. By SAS congruence rule, triangle BAC is congruent to triangle ADC. Therefore, angle BAC is equal to angle DCA, since corresponding angles of congruent triangles are equal. We see that for 2 lines AB and CD, they are intersected by transversal AC such that alternate interior angles are equal. So AB is parallel to CD. This implies quadrilateral ABCD has opposite pairs of sides parallel. Hence, it's a parallelogram. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to BQ. Show that 1. Triangle APD is congruent to triangle CQB. AP is equal to CQ. Triangle AQB is congruent to triangle CPD. AQ is equal to CP. And APCQ is a parallelogram. In triangle APD and triangle COB, AD is equal to CB since opposite sides of a parallelogram are equal. Also given, BO is equal to DP. Angle ADB is equal to angle CBQ. Alternate interior angles of AD parallel to BC. Therefore, by SAS congruence criteria, triangle APD is congruent to triangle CQB. Now let's prove AQ is equal to CQ. We have already proved APD is congruent to CQB. Therefore, by CPCT theorem, AP is equal to CQ. Now we will prove triangle AQB is congruent to triangle CPD. In triangle AQB and triangle CPD, AB is equal to CD, since opposite sides of a parallelogram are equal. Also, BQ is equal to DP. alternate interior angles of AB parallel to CD. So angle ABQ is equal to angle CDP. Therefore, by SAS congruence rule, triangle AQB is congruent to triangle CPD. Next, we will prove AQ is equal to CP. Since triangle AQB is congruent to triangle CPD, by CP-CT theorem, AQ is equal to CP. Finally, we will prove APCQ is a parallelogram. We've already proved AP is equal to CQ, AQ is equal to CP. This implies opposite sides of the quadrilateral are equal. Therefore, APCQ is a parallelogram. Summary. Let's summarize the topic. The sum of the angles of a quadrilateral is 360 degrees. A diagonal of a parallelogram divides it into two congruent triangles. In a parallelogram, A. Opposite sides are equal. B. Opposite angles are equal. C. Diagonals bisect each other. A quadrilateral is a parallelogram if A. Opposite sides are equal, or B. Opposite angles are equal, or C. Diagonals bisect each other, or D. A pair of opposite sides are equal and parallel. Diagonals of a rhombus bisect each other at a right angle and vice versa. Diagonals of a rectangle bisect each other and are equal and vice versa. Diagonals of a square bisect each other at right angles and are equal and vice versa.